my pleasure to introduce Marissa Meyer, who's a Vice President of Product Management. And she's been at Google for about 8 years now. And she was our first female engineer that we hired into the company. So she's responsible for all product management-related activities for Google Search, as well as a variety of other search-related products. Before joining Google, Marissa did her bachelor's and her master's at Stanford and specialized in AI. So welcome, Marissa.
Hi. Today is actually my 8th anniversary to the day at Google, and I guess it's fitting, given that I remember working every Saturday of that first summer that I'm here on a Saturday. But I really appreciate all of you being here and spending your weekend learning a little bit more about Google and our scale and how we approach some of the technical problems. So my talk today is about scaling Google for every user and trying to give you some insights into how do we approach the user experience and how do we think about how we want to advance search. And the first sort of piece of the framework that you need to understand is who the average Google searcher is. And one problem is that all Google searchers are different. They vary by age, gender, location, profession. They're all very different, and they have very different types of tasks. And so scaling the user experience and trying to understand all of these different types of people is really complicated because we have lots of users, and then we also have lots of web pages and lots of data that we need to organize. And so when we think about the overall design principles that we approach the search experience with, there's a couple of core ideas that we try and work with, given that there's such a variety of people and given that there's such a variety of information. And one of those design principles has to do with novice to expert. Should we look at each of these people based on the demographics of gender or age or location? The answer is a little bit. Location in particular is very sensitive to search. The other elements don't matter as much. In fact, one thing that we see is search is incredibly task and actually search specific. The best experience for a particular search usually has to do with that search. And the other interesting phenomenon that we see that's related to this is how quickly people advance from being a novice to being an expert. Because what happens is when we see people use search for the first time, sort of a more naive searcher, they'll do something like, why doesn't anyone carry an umbrella in Seattle? And if you type a query like this into Google, you get kind of irrelevant results about technical careers at Microsoft. So it turns out that actually what you really want to type in is something like, weather, Seattle, Washington, and you'll ultimately get the weather. And people ultimately are able to refine their search techniques really, really quickly. So we see people make this move from novice to much more expert searching, able to get exactly what they want in a really short period of time, usually like a month. So there's certain skills like driving or flying an airplane that can take years to hone. Searching goes really fast. It's a fast process, which means they can iterate and actually change their strategies quickly. And so we see people that they're able to do much more sophisticated searches much sooner. So similar example, where can I hike in the Seattle area? About a month later, you'll see people type something like hike Seattle area and get much better results. So the learning curve looks like that. Their skill level goes way up in a very short period of time. So what does this mean for design? It ultimately means that we aim to design for the expert. So yes, we could make that first month of search more comfortable or more friendly for that searcher. But the truth is they're going to move out of that phase so quickly that we should be targeting our user experience such that it's really easy to use and not annoying and so on and so forth for that expert searcher, because everyone's going to become an expert really, really quickly. And so that means doing things like not having a lot of repetitive text, not necessarily having a lot of help text in the way of the core experience and when you're doing your search. Try not to give people too much guidance. So aim for the expert, but don't intimidate the novice. What you want when you want it. So how do we actually think about new features? Because over the past 8 years, we've actually taken the search experience and added a lot of different things to it. And so when we think about our philosophy, you could be sort of the portal efforts of 1999, where you try and be everything to all people. And you just put all the things that you do right on the home page so everyone can see the whole product line and the whole set of features. And our approach is somewhat different. We want to focus on search and be what you want when you want it. So a few observations. So in the PC world, if you sort of think of it as a graph of features and user experience, the more things you can do with your computer, the better your user experience ultimately is. And so the graph here in the PC world looks something like this. The more stuff you add, the more things that you can do, the better the user experience gets. Then there's things that happen like in the handheld world, where you start to see more of a parabolic curve. As you increase features, the experience gets better and better, but there comes a point when, because the device is so small, you're on such a constrained piece of hardware, if you get to a point where you add too many features, it ultimately hurts the user experience. This is sort of an analysis that Palm did around what happens in the handheld world. And what they really found was that there was sort of a sweet spot in terms of features and what you could do with your handheld. And what we find at Google is that there's two pieces. Both of those pieces actually apply. One is that we need to increase features. And the more things you can do with a search engine and with Google's products, the better off you are. So it looks like the first curve. But the other part of this is that as we try and stay more singularly focused on search and ultimately give people what they want when they want it, that other curve comes into play. So the apparent features, those features that grab you right when you first come to the site or offer you something to do, we want those features to appear when they're relevant in context. So for example, rather than telling you we do translation right on the home page, ultimately, we put the translation features in context. So when you get a search result that isn't in your native language, there's a translate this page link right there. I call this sort of the Swiss Army knife thought, where you can have a Swiss Army knife, and the portal approach is all the functions open, right? So you can actually see all 70 things it can do, but you might actually lose a finger or cut yourself if you tried to approach it that way. So Google's the Swiss Army knife closed. So all the lovely doodads are there. You have the screwdriver, you have the bottle opener, you have all of those things, but they're there when you need them, and they can be sort of pulled out at a moment's notice. And we try and structure the features such that they appear when they're useful. I wanted to spend a little bit of time talking about one of the nice things that we can do at Google Scale, which has to do with the way we evolve the user experience and the way we do user experiments, which is, my background, as you heard, isn't in user interfaces or user experience at all. It's actually in artificial intelligence. And so when I was approached, some number of years ago and asked to spend some time thinking about what our user experience should be like, I didn't know very much about it. So my approach ended up actually being mathematical, mostly because I just didn't trust myself, right? I didn't know which font we should use. I didn't know if we should make it gray or make it black. So I tried to figure out, was there a way we could mathematically figure out what we should do on the site? And the beauty was that because we had so much traffic, we actually could use Google's Scale. So we do what's now known as, we did it then, and now is more famously known in the industry. Actually, Amazon was the other company that kind of pioneered this technique, is split A/B testing, where you take a small percentage of the users and you give them a new experience, or you change their experience. And then you watch that population. So every time they come to the site, they get that new experience. And you watch that population to see what happens with key metrics over time. Do they search more or less often? Do they use this product more or less often than, say, a control group? And it's nice because you can actually find statistically significant differences, even in things as small as color, let alone layout and user flows. And by doing these kinds of user experiments, you can actually figure out mathematically what the right user experience is. There's no more fighting on the design teams of should it be this green or that green, or should it be laid out like this or that. We can just put both of them on the site, run them both in an experiment on a small percentage of users, and then ultimately decide which way we should expand it to 100%. So from that basis, I wanted to show you one of the more interesting experiments that we did, which was one of the first ones. And it had to do with the number of results. So when we first started putting together Google, and this is sort of a shortened and abbreviated result page, we just picked 10 results because that's what Alta Vista did. Right? When you're a startup, you just sort of have to do the expedient thing and ultimately just go with something as sort of a starting point. So we picked 10 results, but at the time, Yahoo was doing 20 results. And I remember Sergey and Larry came to us and they said, should we be running 20 results by default? Should we give people 25 or 30? And so we do two different types of techniques to answer these questions. We do the user studies, where we actually talk to users, probably in numbers of like 5 or 10. Then we also can do percentage experiments. So when you go into the user studies and ask users, should we give you 20 results by default? They say, sure. 25, great. 30, even better, best of all. And so we thought, OK, well, it's clear we probably should give users more results, because they'll be able to find what they're looking for more easily if we actually give them more. So we went ahead and we gave them more results. We ran 3 different experiments, one with 20 as the default number of results, one with 25, and one with 30. So we sort of lengthened the result page. And with the sort of more is better philosophy, right? Like the more results we give them, the better chance they have of finding what they're looking for, the better off we are. And in terms of Google searches over time, we saw things plummet. It was actually the worst experiment we've done to date. Within 6 weeks, we had lost 25% of our searches on the 30 result group. And actually, and for the median group, the 20 results, we had actually lost 20% of searches. So we ultimately saw this huge drop in searches, which makes you wonder, why? Why would we lose all of these searches? Because is it the idea that, are they so much more overwhelmed with all this additional information that they don't know what to do and they're ultimately driven to search less? That's a hypothesis, sort of the paradox of choice. But that doesn't explain why people would start doing 1 out of 4 searches less in a 6-week period. And so then we considered other things, like, well, maybe it's because we actually count the next button as a search, and so people are pressing next less, right? So ultimately, they have to do less searches because they have to go to the next page less. But it turns out, almost no one actually presses the next button on Google. So when we did the analysis of first page searches alone, well, the drop was slightly smaller. It still was really significant. And when you actually, so we were sitting there puzzling over this, and we finally ran a regression test over the logs. We have sort of 15 fields, the cookies, the IP addresses, all of these different things, to try and figure out, was there some field there that varied dramatically, meaning it wasn't a valid control. There was something changing outside of the number of results. And there was. The issue is that in our control 10 results, it takes us about 0.4 seconds to find those and return those to the user. And obviously, when we went to get more results, it took a lot longer. In the average experimental group, it was taking about 0.9 seconds. So it really came down to latency. It's one of these things where they say that perceived behavior is different than observed behavior in psychology. So what the people perceived about themselves, the fact that they would be happier getting more results, was different than their actual behavior and their observed behavior, which is that they were leaving the site in droves. And the difference was that while they wanted more results, the fact that they had to wait an additional half a second to get those results really wasn't worth the trade-off. And what we learned here is that latency and improving our latency is really, really important. So this shows you sort of how we've evolved the user experience and the type of tests we do to try and understand everything from number of results to the structure of the result page and so on and so forth. In fact, what we've now done on these percentage-based experiments is we've rolled out Google Experimental, where you can actually, if you're wondering what we're running on the site at any given time, you can go to Google Experimental. You can actually sign up and log in and become part of the experiment. For the people who elect to be part of the experiment, there's obviously a big self-selection bias, so we don't factor that into the ultimate experimental results. But this is a place where you can go and we can actually get feedback explicitly from our users in terms of what they do and don't like about these new looks and feels that they're seeing in the experimental part of Google. I also wanted to spend a little bit of time talking about improving Google search, why it's hard, and also why it's interesting. And so if you think about the overall search experience and how you evaluate it, there's all kinds of different elements that go into it. We think of them as just searches and queries, but ultimately, you start with the query or the search itself. You should factor in the user, who is sending in that search, their task, the context around what it is they're doing at this moment, and also their location. And the way that they look at the search experience when you're done is actually not only about the relevance of results, but actually the underlying information in the results. What additional information do we provide? How good are those results when they click through to them? And if you think about things, there's all kinds of interesting problems here inside of search. So for example, we know that GM means General Motors, the cars. Of course, unless you say GM foods, which means genetically modified foods. And I think one of the really exciting things that's happening at Google is because we have so much data from the web and so much data from queries, people revising what they're doing, saying GM and then typing in GM foods so we understand that there's another context and that what GM means. It ultimately means that we can do things that almost sort of mirror intelligence, the idea that GM means this when followed by cars and GM means something else when followed by food, is something that because of the amount of data that we have, we're well positioned to do. So if you look at things like this, I thought was a really fascinating example. So if you type in B&B for bed and breakfast, AB, we don't know it, not in the semantic sense, but because of the amount of data, what we're finding is that when people say bed and breakfast followed by something, they usually mean a place. So it ultimately figures out that AB must refer to Alberta, Canada. And if you search for something like Ramstein AB, we know that in that case, it must mean airbase. So trying to, because there's so much data out on the web and because all of these words are used in so many different contexts, we can actually change, it basically looks as if we're changing how that word is. We understand the semantic change, even though it's really just based on the raw data. And search is really hard. We still can't find all the answers. And in terms of user intent, that's the ever-elusive thing that makes search really interesting and also really compelling. So when you think about sort of the span from easy to hard, and think about user queries, given a user query, what Google should also try, there's some things that are simple that we do right now. So if you look for unchanged lyrics Van Halen, even though unchanged is an actual word in the English language, because of the context we have in terms of all the data, we actually will suggest the lyrics to Unchained by Van Halen, right? Because we know from different revisions that ultimately Unchained is what the person's looking for. But things get much harder when you start thinking about free-form questions. How much does it cost for an exhaust system? And we ultimately should really be doing a query like cost of an exhaust system. And then, of course, as we go down the spectrum to harder, there's things like overhead view of Bellagio pool. How will we ultimately build the understanding? This is some of these uncharted territories that overhead view really means a picture. That what you should really search for is Bellagio pool pictures, and again, you'll get the right result. And then F-15 launched from a submarine, that you actually are looking for a submarine launch. And then things that are even more complicated, where the piece of information exists, but it's not obvious what the chain of logic should be to find it. Something from distance from Zurich, Switzerland to Lake Como, Italy. The easiest way to find that is actually to look up the trains from one place to the other in Europe and find the time there. So these are the types of things where if we had the perfect search engine, all those types of queries on the left would be interpreted and executed like those queries on the right. But building that level of intelligence is really challenging. And I think that's one thing that makes search a really interesting problem. It's very large scale, it's highly multidimensional, and it's a not well-defined problem. So I also wanted to spend a little bit of time talking about some of the things that we think are going to advance search a lot in the future, as well as some of the exciting technical problems around it. And one of those things is scaling internationally. We have a demo that we released last month that shows sort of the cusp of a new piece of technology that I think is a really non-intuitive way to improve search, but does really work. And it's called CLIR, Cross-Language Information Retrieval. And what we're attempting to do is use the automated translation engines that we've developed to take people's queries, translate them into different languages, and then search the web for documents that match all of those translated queries, bring those results back, and translate them into the native language. And so right now what we have up in terms of a demo is something that works like this, and I apologize for you in the back. I'll just sort of narrate the way this looks. So what you can do here is this is Arabic to English. So right now we're doing single language pairs. But you can type your query in Arabic there in the search box, and it gets translated into English. So this is restaurants in New York. And then you say your current language is Arabic, and you want to find results in English. So we take that query, translate it using our automated translation engine to restaurants in New York, search English pages for restaurants in New York, get those results back, and then use the automated translation engine to translate them back into Arabic. So for the end user, they typed their query in Arabic, and they got their results in Arabic. And so it's a seamless language experience for them. And right now, we're doing these pairwise, and obviously automated translation, even as good as it is and as much as we've invested in it, still has a ways to go. But when you think about what this could do for search, it ultimately means if your answer is out there, if it's written in any language, you can still find it. And it's really compelling. And for English, it may end up not being as important because so much of the web is written in English. But for a country in a language like Arabic, what you ultimately see, or I should say a language like Arabic, what you see is that only 1% of the web is written in Arabic. So when they do a search, there's just not nearly as much information to answer their query with. So by having a technology like this, we can really unlock all the great answers and all the great search results that are on the web and bring them back to them in this language, in their native language. And then, of course, when you click on those results, you ultimately get driven to pages where we can, again, use our automated translation engine and translate the full page. And this is another example about typing tests of words per minute, because it turns out there's no typing tests on the web for people who want to try out their typing speed. For Arabic users, there's lots in English, and it turns out you don't really need to understand the instructions all that well to get a count. So this is a way where you could actually find something that doesn't exist on the web in Arabic by using this type of translation tool. And so, as I said, I think the real power is using this across multiple languages, finding the best answer, bringing them back, and making it a seamless language experience. Then there's universal search. So in the middle of May, how many people heard about Google's universal search announcement? So in the middle of May, we retooled the search engine to try and expand from our classic 10 text-based URLs to introducing much more rich types of information into the result page, things like books, videos, images, news, and local results, all onto the search result page. And universal search has a couple of interesting problems around scale. So this is an example of what we're trying to do. So it turns out Nosferatu was the original monster movie. It defined the whole sort of Dracula scary movie genre, and it was made in 1922. And so up until we released universal search, when you searched for it, you got a great result from the IMDb as your first result. And it had lots of good meta information, things like the director, the actor, the running length, so on and so forth. But what we see here now is that with the power of universal search, we actually have a video of it right on page. And not just any video. It's not a video clip. This is the full 84-minute movie that was uploaded to Google Video. So you don't just have to learn about Nosferatu on the meta level. You can actually just watch the whole movie right here in page. And it's these kinds of much richer, better answers that we're trying to provide with universal search. Sometimes the right answer isn't just a URL or a text link. Sometimes it will be something that's much more rich and experiential, like this video. But universal search has a couple of key scaling problems that make it interesting. One is, if we actually want to bring in results from all of those different corpora, what we have to do is run the search on all of those different corpora, which means that right now, we get a lot of search on main web search, hundreds of millions of queries a day. But something like Google News or Google Book Search may only get single-digit millions or tens of millions of searches a day. And so if we want to scale it up such that every query Google's given we can actually go and search those corpora, we had to think about how to totally change the representation, the data representation. How do you change the way that you store the index? How do you make it computationally feasible without multiplying up our entire infrastructure by tens of thousands, if not hundreds of thousands of machines. So the infrastructure problem here is something that we ultimately had to address. And some of the people that you've heard from today, like Jeff and others, are some of the people who thought about how we should roll out a new infrastructure. So universal search represented bringing out new infrastructure to run these kinds of queries and make this computationally feasible. The next big problem that we had was, once you have different types of content, the equivalent of apples and oranges, how do you rank it? Which one should go first? Apples or oranges, right? How do you decide? Should a book go first? Should a video go first? Should an image go first? How do you decide, once you get all those results back from all those different indices, how to mix them together and ultimately understand the relevance? And the other problem is that when we're looking at all this, each type of index has a different type of signal, right? So in books, we know the page number that the word appeared on. On the web, we have much richer things like link structure, the bolding, the italics. There's all kinds of different signals. And so when you try and sort this out, it turns out the scoring functions aren't that interesting. It's as if you were to say, what should we put first, apples or oranges? In terms of US consumption, turns out you'd want to put oranges first, so 80 pounds of oranges per person versus about 50 pounds of oranges get consumed per person per year. But if you look at something like fresh, how much fresh stuff gets consumed, it turns out many more fresh apples get consumed than fresh oranges. And then, of course, the most valuable crop in the US is actually grapes. So you get the idea that with all these different types of items, how do you blend them all together? And that's one of the things that Udi Manbar and our search quality team looked at. How can we roll out a ranking function that does a good job normalizing across all of those different indices? And then finally, there's the user experience problem, which is what I worked on with my team. Of once you have something that's totally different and really disruptive, where do you put it in the search page? And how do you actually get to the point where users can find it, but you don't have something like presentation bias where someone ultimately notices something to a larger degree than they should relative to relevance and so on and so forth. So should images always go on the top? Should news always go on the top because of its urgency? Should we interleave it into the results? How should we represent these different entities? These are all the types of questions that we asked. We sort of talked about segmented versus blended view. Should we show each type of result in a segment of the page? Should we blend them all together? And should you have fixed placement or variable placement? Should where the results show up always be fixed in the same order so it's easy to find and navigate, or should you actually vary where they show up? And our first attempt, what we did is we just took the normalization function, ultimately gave good contextual cues as to mediums, like a thumbnail if we have a video there, pictures for images, news headlines, and dates and times associated with them, to give the user some insight into the medium. But in terms of the ranking and segmentation, what we ultimately decided to start with was just an ordered list, which is what people are used to with search. Just put it on the page in rank order, give some clue that this is a different type of result visually in terms of the layout of that result, but lay it out that way. And that's just a first attempt. I think that there's clearly going to be ongoing research in terms of the right way to deal with all of these heterogeneous types of results. And then finally, there is how to make Google personal at scale. And a few years ago, there was this big announcement, which some of you might remember, about Stanford University students who found out a way to make Google faster. Do people remember this? It was sort of interesting because it's sort of a case of computer science and journalism gone wrong because what it turned out is there was a team, Sep Kamvar, Taher, Glenn, over at Stanford who had found something really interesting. They had found a faster way to compute PageRank. And of course, the journalists understood that PageRank was part of Google, and then ultimately thought, well, this means that Google will be faster because we can now compute PageRank faster. So all these headlines, blanketed the news the next day that now someone could come up with a faster Google. And of course, this doesn't totally make sense because PageRank is computed offline long before your query actually gets issued, as opposed to in real time. But there was something interesting here. We ultimately ended up they formed a small company, and we ended up acquiring them. The idea was that what they had found is if you made a component, sort of a component structure of the web where you grouped things and sorted them by host, by looking at just the connections between the components, you could actually do a computation of PageRank, looking at the link structures across those components, that was far more efficient. And frankly, we hadn't been worried that much about making PageRank very efficient. It runs across hundreds of computers, and it takes about a day to converge using different mathematical approximation methods. But it was interesting to think about making PageRank much faster to compute. Because while PageRank would still be computed offline, it could, for example, allow us to compute multiple PageRanks. So it turns out the PageRank function itself, our measure of importance, is very sensitive to the seeds in the equation. So depending on how you start the PageRank, how you see the PageRank algorithm, you ultimately get very different types of answers in terms of importance. So what this would allow us to do is do something like compute a PageRank per country. So for example, we could seed PageRank with all kinds of different URLs from, say, the UK, and compute a UK-specific PageRank, which might help us get more relevance there. But even more intriguing, we could actually look at pages people visit and use and click on the web and compute a personal PageRank for each person. So we could actually create a personalized search engine. And ultimately, that's really the advance of what Sep and Tahir and Glenn were working towards. And so we brought them on board at Google, and they developed our personalized search engine where you can sign up for it. It keeps track of, and the search history, it keeps track of your overall queries and where you click in the results. And then using that, they ultimately compute a vector over the web by which we re-rank your results in line with this type of PageRank computation. So you actually end up with sort of a personalized sense of what's important to you when you use the results. Other interesting things that we're doing in personalization that sort of veer far from search but are still related are things like our iGoogle page. So this is our personalized homepage that we offer on Google. And I think there's a couple of interesting technical things here in terms of what's happening, both technically and in terms of strategy. One is that this is an open platform. So these little modules down here on the bottom are called gadgets. And we have developers all over the world working with our API and now a wizard called the Gadget Maker to create these gadgets. And it's really interesting to see what people create. People will create slideshows, you can do games, weather, news, and this has been our fastest growing product. It's on a relative basis, its scale and growth is comparable to YouTube. People are really responding to having this kind of personalized content on their homepage and this type of rich functionality. But from a developer standpoint, there's all kinds of interesting things happening here. So for example, there's one teenager who's 17 in Arkansas named Caleb, who's our #1 gadget developer. And he basically made a bunch of gadgets that are super useful for high school students, like periodic tables. And so if you're a high school student, what you really want on your homepage is a periodic table. And it turns out that Caleb, in aggregate, across the 10 or 12 different gadgets he's created, actually gets 30 million page views a month. So he gets a huge amount of distribution of these gadgets. So for website developers, for companies, building a gadget is a great thing to do because what it ultimately means is, well, someone might not make their full homepage a periodic table, just like on my homepage I have my Netflix queue. I would never make Netflix my homepage, but now Netflix can participate on my homepage by having a gadget. And so we're seeing a lot of interesting growth in gadgets. And it ultimately means a few things for us. One is there's this personalized experience that gets people to come back. It ultimately causes them to search more. And as part of searching more, that helps us improve our algorithms. But it also helps us learn a little bit more about them. And then when you look at taking things like their search history, their activities on personalized search, and iGoogle together, what we ultimately are hoping to build is something where the search engine really understands who you are and what it is that you want. So sort of you plus Google being a sort of joint search engine. So personalized search is, I think, one of the most interesting things that we're going to advance in. Because when I think about the future, what I really think about is, what will the lead search engine be like in 10 years, right? Because 6 months out is really, well, kind of easy, right? Because whatever we're going to release in the next 6 months is probably in production and being built right now. 2 years out is really hard because there's sort of weird stochastic changes that can happen in the environment in terms of what might get built or what might advance technology. But if you think 10 years out, there's just some things that have to be true. Like the search engine 10 years from now has to be better than Google today, right? Google today is better than it was a month ago or 2 months ago. So there will be a search engine 10 years from now, and it will be better than Google is today. And if we think about why will it be better, I think part of that answer has to be that it will understand more about the user, which will help us get closer to that sense of user intent that we ultimately saw earlier. Maybe it will just be that it understands where the user is, or a little bit about their overall preferences and the types of searches and what they've already read on the web so we can produce new and unique results. But it's those types of elements of personalization that I think are going to be part of the search engine in the future. Maybe not the exclusive reason they're better, but a big part of one reason why they're better. So with that, that's the end of my formal presentation, and I have some time for questions. Yeah?
Does your focus on experts de-emphasize natural language processing?
Not necessarily. Well, I think you could sort of say, well, to the extent that novice users often type. Oh, sorry. I need to repeat questions. So the question was, does our focus on the expert ultimately cause us to devalue natural language processing? I don't think it necessarily does. There certainly is a lot of interest and work at Google thinking about natural language, though I would say it's probably more in things like voice to text and other elements there. So for example, we rolled out our new service 1-800-GOOG-411, where you can actually call and speak queries, and there's all kinds of reasons voice to text would be really useful. I do think that what we see is a lot of times when users start out, they end up doing more natural language questions, and as they evolve, they start to understand the concept of keywords. I don't necessarily think that's good. That's one thing that ultimately makes the search better, but my view is that searchers should be able to express themselves the way they feel comfortable, as opposed to conforming to our approach. So the fact that our approach is so keyword-based that they ultimately need to learn to be keyword-based is sort of a minus, right? It would be better if we actually got smart and learned to do natural language too. It's just that natural language, as you know, is really hard. Other questions? Yep.
So when you mine the user data in terms of being able to refine the data to understand what the textual associations are, et cetera, how do you work that in? I mean, is there an engine that's constantly processing that, coming up with new sets of associations that then become part of the corpus, or how does that work?
Sure. So the question was, how do we, when we mine associations and we mine refinements and things like that, how does it work in terms of folding those observations and those findings back in? And the answer is we have, as you can imagine, a lot of data coming into Google at any given time, from the crawl to queries, so on and so forth. So there's all kinds of ways that we process that data. Most of it happens offline and then gets uploaded in either nightly or hourly builds of data. So for things like personalized search, we do a computation that I think runs about twice daily that folds in the latest elements of your search history into your personal profile. So there are things like that. So there's constantly offline processing running, and they happen at different periodicity depending on the product. Yep.
How is universal search going? I mean, you said the Google is doing really well, but how about the other?
Well, sure. So the nice thing about universal search is we actually replaced the main engine. so I think the answer is universal search is going as well as Google search is going. And so things are going pretty well. We always see a little, we always see a little bit of a slump in the summer, but in general traffic is up, and we're pretty happy with it. And users are responding really well to it. So we're starting to see the overall benefits of people finding a video or finding a book, and the increased traffic to those properties also seems to indicate that universal search has been a net win. I think that there's a lot of immediate challenges, right, in terms of like once you roll out a big infrastructure change like that, there's always lots of things to fix and lots of new problems to consider. So for the first time this year, I look a lot at our traffic graphs to try and understand what's growing and where we should allocate resources and how to prioritize. For the first time this year, I saw something really interesting happen, which is as our sort of traffic sloped down a little bit over Memorial Day, which it always does, interestingly, our mobile traffic went up in this nice little growth curve that almost perfectly corresponded on a percentage level to our traffic slope off. So it was almost as if you could actually watch our traffic and see people shutting off their computers and going outside and doing searches from their phone. So I thought that was really interesting, but that also made it much more clear to me that the advances of what we're doing as part of web search that you do from your laptop have to be reflected in the phone, which of course the universal search has lots and lots of interesting problems. Is it a follow-up question? Or? Okay.
You mentioned traffic, and that's like your metric. I know Amazon uses the metric of like who paid more or who bought more products. So like, is your only metric just number of page hits, or is it also like, do they click on the ads more often, things like that?
Sure. So the question was, what is our primary metric? Is traffic our primary metric? And the answer is usually what we do to make sure with, let's say, one of the split A/B experiments that we actually have a definitive actionable answer is we'll usually define a primary metric. So for example, if we're changing the appearance of the ads, we'll have the primary metric be RPM, revenue per 1,000 pages. And so if that goes up, that ultimately means that these ads are more effective than the way we previously were displaying the ads. If there's something with like universal search, which we do experiments on, and we actually did experiments leading up to the big launch in May, We look at things like overall traffic, traffic to the specific properties that are linked off of universal search and how we drive traffic there. And then also things like normalized traffic, because it turns out looking at traffic overall, especially on a global scale, it's incredibly sensitive to world events. Someone has a holiday in this country and you can see it, right? You know, the Olympics happen or there's a big news story and it really causes traffic to fluctuate a lot. So you need to look at more normalized metrics like searches per user, things like that. Yep. Mm-hmm.
I was interested, on our site we use a somewhat less scientific mode of A/B testing. I was wondering if you've seen any interesting numbers in terms of like people's resistance to change when they're already used to a certain feature.
Sure. So the question is, in less sophisticated environments of split A/B testing, you know, and also probably Google as it's grown over time, have we seen resistance to new things that we put in the split A/B testing? And the interesting part is that for end users, not so much. It's interesting. My mother is very detail-oriented, and she's an art major, and was an art teacher. And like, I'll show her 2 different designs, and she can't tell the difference, right? Because like the changes that we make are very subtle, and we're usually measuring really small things. Interestingly, the most resistance we get is from inside of Google. And of course, as the employee base has grown, that means that the resistance gets larger and larger, right? So you change something small, like the color of the bar on top, and they're like, it's ugly. Change it back. Or like, actually, I had the same reaction last fall. We changed the top line of our ads to be in the standard font size rather than font size -1. And when I did the search the first day, I looked at all the experiment results. It seemed like a good change. We changed it on the site. The first time I saw it, I was like, I'm blinded. The ads are screaming at me. Look, they're so big. But I think it's because we use Google so much that you get really sensitive to any small change. Because like 3, 4, 5 days later, I was over it, and I didn't even notice anymore. So I find that the most resistance is actually internal. Yeah.
With universal search, how is Google dealing with the bias of the search results as different types of search results are being used? Books and videos.
Sure. Well, so bias and also the flip side there, which is user trust, is a really important issue for us because search is ultimately a learning mechanism. Right? So if you think in some ways of like, how do you learn something from a teacher, you need to trust the teacher. You need to know that when you go and ask a question, you're getting the best answer, not the best answer that that person was paid to give or the best answer that person was predisposed to give. And so it's one reason we've ultimately tried to be very clear on our ads. So we always put a pastel background on them or put them on a special part of the page, label them very clearly sponsored links so people understand when our answers have bias. That said, with universal search, that's our objective search results. And so we're introducing things that are very agnostic in terms of very agnostically in terms of which corpora they come from. This is also one reason why Google has been hesitant to be a content hoster or a content creator. Because to the degree that we host content, we ultimately have a monetary incentive to drive people to those pages if those pages have ads on it. So while there are some times when we've had to, almost from necessity. So for example, we host videos on Google Video and on YouTube, but that was just because the video experience was so broken across the whole web that if we did video search and let people click and go to a page where they actually couldn't see the video, we thought that was worse. But we've been very clear about our monetization. And books was a similar item where a lot of the publishers didn't have the capacity to host their books. So we've hosted them. But we've been very clear about our policies there about monetizing. In terms of the way they were introduced into universal search, we've tried to be agnostic. And in fact, for videos, we not only include things from Google Video and YouTube in universal search, but we include all major video hosting sites all over the web, including MetaCafe and others. Yeah. Mm-hmm.
I noticed that when I searched for like YHOO, it showed the stock quotes. It used to be that Yahoo Finance was the first link and now it's Google Finance. Is that based on data or that Google Finance?
So the question was, on our stock quotes, when you type in different tickers, you see little charts appear on the top of the page. And we used to have Yahoo first, and now Google is first. And I think the answer was that, if I recall history correctly, we didn't actually have Google Finance until about a year ago. So up until then, we were actually ordering the links based on various published metrics like ComScore and media metrics. So we had the 5 top finance sites in their order of popularity listed there. So when we rolled out Google Finance, we did put the Google link first. So seems only fair, right? We do all the work for the search page and all these other things. So we do put it first. And that's actually been a policy then. Because of finance, we implemented in other places. So for Google Maps, again, it's the first link, and so on and so forth. And then after that, it's ranked usually by popularity. Yeah.
How do you detect not programmatic bugs, but information errors? Say something goes through your calling process and it causes the system to work with misassigned indices. That has a huge impact on the user base. How do you even find out about that? You can't QA the web. How do you detect that from a user standpoint?
So let me make sure I understand the question properly. So you're looking at information processing errors. So a query coming through the system, if it gets routed to the wrong indices, or even, or just returned results that just weren't as relevant. So it's an interesting question, it's an interesting problem, and it's one that has, I remember thinking, when I first joined Google, that it was really hard for us to figure out, were we actually producing the best results on the web? Because the other thing is, universal search makes this even more complicated because we're hitting different content types. But as you can imagine, we can't fit the whole web or our entire postings list on one computer. So you ultimately hit 40 different computers and then stitch the results back together. And what if one of them is down or just kind of conks out in the middle of what it's doing? And we have all kinds of sophisticated systems that watch this. So in terms of the actual operations of our systems, we actually literally have what we call babysitters that are constantly checking the health of all of our machines, right? Are all these index servers, the doc servers, the web servers, are they up? Are they answering? How overloaded or unloaded do they seem? We're constantly checking things like that. In terms of quality assurance, we actually have a bunch of different ways of looking at this. One is in terms of advancing our quality, as we try and change the signals in our ranking behavior, we have evaluators all over the world, literally several tens of thousands of them that log onto consoles and rank, is this query and is this URL a good answer for this query? So they're constantly helping us understand and get a good benchmark around what is a good result for this. So we know when we roll out a new evaluation function, does it seem better by those hand evaluations? And then, of course, the real-time checks that we have to do with monitoring the system and the way users are responding to it. So for example, given the large number of queries, it turns out that the percentage of time the first result or the first ad is clicked on is pretty stable, right? Because we're just averaging over such a large base. And so if that starts to swing dramatically and we're seeing either less click activity per page or a different distribution, that usually lets us know that something's going wrong. So we have all of those different systems monitored. So those are the types of things that we do to make sure the machines are healthy, make sure any advances that we turn out are actually advances in aggregate based on a benchmark, and then monitoring the systems in real time. Yeah.
Recently, you made some changes to try and catch Google bombs because I believe Matt Cutthroat wrote a blog that some users felt that those were Google's opinions about some of those results. So what's the process for deciding if you're going to hand tune some results?
So I'm not aware of hand tuning we did with Google bombs. I know that we have actually looked at automated processes to try and find Google bombs. Google bombs are hard to find. So are you all familiar with Google bombs and how they work? No? Okay. So what happens with Google bombs is someone basically tries to own and or embarrass a particular query or entity. So for example, if you take two common words that don't occur frequently together on the web, like the word miserable and the word failure. They both occur a lot on the web. They don't occur together a lot. And so what someone will do is they'll say, hey, let's make miserable failure mean something on Google. And they put up a big blog post and say, why don't we all link to this page about George W. Bush? And so everybody put a link on your page and link to this page. And then it'll be really funny because on Google you'll type in miserable failure and this page will come up. And so that's sort of the spirit behind Google Bombs, and that's how they work. And it's actually really hard to catch because that linking behavior of a new set of terms appearing on the web and all linking some new place is also the same linking behavior that you see on blogs. Right? So, the OK Go treadmills video appears on YouTube. Have you guys all seen the treadmills? They're great. Anyway, so they're really popular. They got millions of views. Everyone's watching these guys dance around on treadmills to a choreographed dance to the music. And so the same thing happens, right? Everyone says OK Go treadmills and links to that video on YouTube. And that's ultimately what drives the link structure and PageRank and a bunch of other things that make Google work. But the same thing's happening now with miserable failure in a way that really wasn't intended. So it's hard to find, and even when you're looking at snapshots, right? Because one thing we thought was maybe it's temporal. Maybe you can see because all those miserable failure links appear so quickly that that's a sign. But it turns out the blogosphere ultimately means that even finding it temporally is hard. So it's something that we've looked at a lot. We found some techniques that work. We have some techniques that have false positives, and I know we've rolled out some changes to it. Larry Page, our founder, actually makes a very interesting observation about this, though, which is that one of the problems with Google Bombs, and there's been about 4 or 5 very famous ones over time, is that they become famous and they become talked about, right? So everyone's running around talking about miserable failure. So then when you search for miserable failure, actually being able to see the Google Bomb or our explanation of it, because we'll put an explanation of it up on our blog, that's actually the right answer because the people who are typing that are actually looking for evidence around what happened for the. So it becomes a sign of self-fulfilling prophecy or self-referential prophecy that that's really quite strange, but ultimately kind of ends up working out. So yeah. Sure. So the question was, what percentage of the web do we crawl, and what is the limiting factor in terms of growth? And so let's see. There's a couple of different answers to that. We try and crawl almost everything. There's certainly some types of content that we don't do as well on, things behind sign-ins, various databases where we try and, what we're doing now with databases is actually allowing people to send us feeds of data to Google Base so they can actually just give us all that attribute data in one sensible way rather than us crawling and infinite looping and getting the same data again and again. So there's some places where we can't do as well, but we try and get as much of the web as we possibly can. The one issue that we have, or that I see, is that to produce the kind of really precise and relevant results that we have very detailed postings lists, right? We need not only to know that this word occurs on this page, but we need to know where it occurs on the page. Was it in bold? Was it in italics? What was the exact position so later we can do proximity checks for the words? And the postings lists are super detailed, and they actually go into 100, maybe even 150 different facets of a particular postings item. And so as you start going towards tens of billions of pages, well, you want to have really deep information like that on the top few billion pages. The rest of them, you don't want to expend quite as much sort of linear energy on them. And so how can you have an index that's smaller in terms of the postings list and the amount of data that's stored, but still allows you to accurately find results? So if someone types something really obscure and it's not sort of in that top chunk of the web, you kind of fall through to this index that doesn't have quite as much data, still allows you to do the basic search and produce relevant results. But so those are the types of techniques that we've ultimately worked on in terms of, can we have different amounts of information in different indices such that as we scale and get larger, we still have a way of producing a good result, but it may not have the same precision that the top part of the web has. In the back.
So, all queries are still entered with text. How long will it be that you can search for like a face or a tune or
Sure, there's a lot, and there's a lot of interesting problems there. So the question was, we're very text-based and keyword-based still. So how long until you can search for a face or search for a tune? So things like a visual search or an oral search, where rather than rather than entering in text, you ultimately enter in a picture or enter in a few hummed notes. And I think a lot of these techniques having great groundbreaking efforts published. And if you look at some of the interesting papers that are happening in academia on visual search, they are showing real advance, but they're still at a place where they're 50% accurate, 60% accurate when you're searching for faces. And well, that's very interesting from an academic standpoint, and it shows that the science is advancing and may someday get where we're going. In terms of end lay people users, they just don't understand when a search is wrong half the time, right, or makes a mistake half the time. And of course, when you're wrong on half of the results on a page of 10 images, it's just sort of beyond what they can comprehend. So what I think is actually much more likely to happen as an advance instead is, for example, on image search, we look a lot at the associativity of the text around the image. So what around that image can tell us what's there. So it's still a very text-based approach, but it's sort of more sophisticated in trying to understand what words associate with this picture, what words describe this picture. Can we understand that it says, Eric is on the left and Sergey is on the right. Can we, do that kind of understanding? And on video search, I think, again, while those visual means are still coming along, I think it's much more likely that early advances in video search will come from voice to text technology, which in my opinion is much further along, and being able to extract voice out of the video, build a text transcript, and then search over that. So those are just my own personal speculations, but I would guess that the advances in image search and video search over the next 2 to 3 years on what's available to consumers are much more likely to come from text associativity and voice to text advances. Yeah? Mm-hmm.
In terms of measuring the success of search, you mentioned click-through rates, which is what Tom's spoken to as well. But for an example, like you use for a ticker symbol where click is not happening on the search results page, how do you internally measure that as a success?
Sure. So the question was, for something where you actually embed the information in the page, so for a ticker symbol where we give the stock price right on the page, or for a map where the map is right on the page, how do we measure success? And it's a frustrating dynamic, actually, sometimes with teams, because we're so used to everything being so measurable on the web. You can say, my product is useful to people 17% of the time, and it's really great to actually be able to know that number. But what we try and avoid is actually people hiding information away for the sake of achieving measurability. Right? The idea that don't take information that could just be embedded in the page and put it on a separate page behind a link just so people have to click so you can measure it. And that might be frustrating because you ultimately lose measurability. It's actually better for the users because they're one step closer to the information. So what we do there is we do a lot more of the hand evaluations that I talked about with those tens of thousands of people logging in. We also look at queries of, say, the case of where like a stock ticker shows up first or a map shows up first, where there was no further click activity on the page. There, it's a loose approximation. It's not the precisely measurable, hey, they clicked on it, they must like it, but because, for example, they could have just decided to go search somewhere else or walked away from their computer unhappy. But the idea that they got that page and didn't do anything further with it usually means that they were happy. And we can also look at, for those users who got the piece of information, what percentage of them clicked elsewhere on the page. Because that usually is an indication that they weren't satisfied with that information we embedded. So those things ultimately help us approximate. So while we lose full measurability, there still is a concept of an overall sense of success and user satisfaction. So I think I have time for just one more question. Yeah? How did we what? Oh, so the question is, how do we deal with spam? And I realized a while ago that spam means so many different things at Google because we have spam in the search results, people who are trying to trick us into thinking that a result is good for a query it's not good for. We have query spam, people who send us lots of nuisance queries just to measure things or just to try and overload the service. And then, of course, now with our Gmail product, we also have mail spam to deal with. So we have lots of people all over the company who are working on spam, how to find it, how to root it out, and how to get rid of it. I think the most notable form of spam that relates to search is the spam in the result set. So again, there we try and have a very clean, technical, objective, automated approach, which means trying to understand what are the link patterns around spam. So sometimes, for example, you can look at link structures on the web and you can say, well, look, if this page really was authoritative on this topic, how come only pages on this domain, or only pages on these 5 domains point to that page? That's really funny, because if it was globally authoritative, you'd see more links. So you can kind of look at, you can do a local connectivity analysis and try and understand if something strange is happening there. There's also other means. So, for example, one of the most popular forms of spam is called cloaking, where, when our crawler comes through, we declare it as Googlebot. So a website knows when Google's visiting. And so what they'll do is they'll serve a different page to us as Googlebot than they'll serve to a user later. So for those types of things, and that ultimately we feel hurts our users, because we served up that result thinking that page said this and was relevant to that query. So if you're going to serve them something else, we don't know if that page is relevant anymore. But it ultimately means, again, you can imagine there's an easy way to check for this. So when we'll sometimes have the crawler come through with the Googlebot user agent, and we can have other tests go through using a classic end user agent like IE, right? And actually see, aside from ads and other sort of cosmetic changes, are we still fundamentally getting the same page in the same context? Or so we have automated ways of checking on things like cloaking, checking on things like strange link patterns on the web that might mean this isn't really authoritative on this topic. So those are the types of ways that we address result spam in particular. Well, so with that, I want to thank all of you for your time and attention, and I hope you have a very good rest of the conference. Yay.